All right, we're going to get started talking about momentum. So, we're going to link Newton's first law with momentum. So Newton's first law, as you remember, an object in motion will stay in motion unless it's acted on by an unbalanced force. So I know it could also say an object at rest will stay at rest unless acted on by an unbalanced force. But we're going to be talking about objects moving. And momentum expresses the resistance of a body to slowing down or speeding up. So momentum is really tied to inertia. So remember, inertia was that resistance to change. So if an object was sitting, it has inertia, it wants to keep sitting. If an object's moving, it has inertia, it wants to keep moving. Now, remember, with inertia, inertia was also tied to mass, right? So the more mass an object has, the more inertia that it has, which makes sense because think about a puppy and a horse. A puppy, very little mass, very little inertia. If a puppy wants to sit, well, you could kind of still pick it up. But a horse, if a horse wanted to stand still, I mean, it could really fight you and pull against you because it has so much inertia to where it would be very difficult to move. Momentum's the same. So momentum can be defined as mass in motion. So we have some sort of mass, some sort of body, some sort of object, and it's in motion, it's moving. It may be moving slowly, it may be moving at an average speed, it may be moving very quickly, but in some way, shape, or form, it is moving. All objects have mass, so if an object is moving, then it has momentum. So it has its mass in motion. So momentum, it depends on the variables mass and velocity. So mass, because all objects have mass, and velocity, because we are talking about objects in motion. All right, so when we go to calculate momentum, momentum is actually represented by a P, as you see here, because M is already represented by what? Mass, right. So to make things different, because we're going to be talking about mass and momentum, two M words, momentum has a P letter to represent it. So momentum is calculated by mass times velocity, or P equals M times V. So remember, P is momentum, M is the mass, and V is the velocity. So with this equation definitely illustrates that momentum is directly proportional to an object's mass, meaning if you were to increase the mass, you're going to increase the momentum. Or if you were going to increase the velocity, it's going to increase the momentum. So momentum is directly proportional to the object's mass and velocity. So if you increase the mass, you increase the momentum. Or on the other hand, if you decrease the mass, you take away some parts of the object, you decrease its mass, it's going to decrease the momentum that the object has. All right, units for momentum. So we said that the equation is P equals M times V, right? Well, P is a momentum. Mass, we know the SI units for mass is always in kilograms here in physics, times the velocity. And we know that velocity, the units for velocity is always meters divided by seconds, meters per second. So the units for momentum then would be kilogram times meter per second. And yes, you have to write those units every single time to get credit. All right, momentum is a vector. So remember, we've been talking about vectors. Vectors have two parts, right? One part is the size or the magnitude. And then the other part is the direction. So the direction meaning, is it left, right, positive or negative? So vectors have two parts, magnitude and direction. And momentum is a vector. So it's a vector quantity, so it has magnitude and direction. The direction of this momentum, so the positive or negative sign, the left or right movement of momentum, is tied to the direction of the velocity. So if the velocity is going to the right, the momentum is also going to the right. To fully describe the momentum of a 5-kilogram bowling ball moving westward to the west at 2 meters per second, you would have to use the equation M equals M times V. So you plug in your numbers, P equals, well, our mass was 5 kilograms times our velocity, which was 2 meters per second. So you know that the momentum, 5 times 2 is 10, so it's 10 kilograms meters per second. and westward. Because remember, momentum is a vector. It has both parts. The magnitude, 10 kilograms meters per second, and the direction, westward. All right, we're going to have a couple of practice problems, so that way whenever you're on your own, you know how to do this successfully by yourself. So a toy car has a mass of 5 kilograms. It is moving at a velocity of 4 meters per second. What is its momentum? So we are given, and of course, as always, you do not have to set up your work in the guess method. You can use it, or you can do it however you would like. I'm going to use it just so I like to stay organized. So our givens, we have mass equals 5 kilograms. We know that our velocity was 4 meters per second. Our unknown, well, it's asking us what is the momentum. So we know our momentum is the unknown. And remember, momentum is a P. Our equation, momentum is mass times velocity. So now we just need to substitute. So P equals, our mass was 5 kilograms, times our velocity of 4 meters per second. And we assume from the problem, it doesn't give us a direction, but it is a positive 4 meters per second. So the momentum is also going to be positive. So that means that the object could be moving to the right. So we're going to solve. 5 times 4 is 20. And our units is kilogram meter per second. All right, perfect. Next one, what is the momentum of a 25 kilogram boy moving at a speed of 1.2 meters per second? So our givens, our speed or our velocity is 1.2 meters per second. Our mass of the boy is 25 kilograms. Our unknown, well, we're looking for momentum again. We know that our equation is P equals M times V. So now we need to substitute. Our mass was 25 kilograms times our velocity of 1.2 meters per second. And that is going to give us 30 kilogram meter per second. All right. So let's look at these scenarios. So a car possesses 20,000 units of momentum, right? So P equals 20,000 units. So the units for momentum, of course, are kilogram meter per second. And just a refresher, we know that our equation for momentum is P equals mv. So what would be the car's new momentum if its velocity was doubled? So let's say P equals mv, and you double the velocity, right? So now it's a 2v. Well, if you're doubling the velocity, then you're going to be doubling the momentum, right? So it's going to be twice as much for the momentum. So twice as much would give us 40,000 units of momentum, or kilogram meter per second. All right, now if the velocity was tripled, well, if you triple the velocity, so P equals m times 3v, that's going to mean that you have 3 times the amount of momentum. So 20,000 times 3 is 60,000. So if you triple the velocity, you're tripling the momentum. Okay, C, its mass was doubled. So maybe you're adding more passengers and a greater load to the trip, to the car. So the mass was doubled. So now P equals 2m times v. So you would have twice as much as momentum. So you would go back to having 40,000 units of momentum. So if you double the mass, you also double the momentum. And now for D, both the velocity was doubled and its mass was doubled. So you would have the momentum equals twice the amount of mass times twice the amount of velocity. So that would be 4 times the amount of momentum. So times 4. So 20,000 times 4 would give you 80,000. So I hope you see the pattern that if you double the velocity, then you double the momentum. If you triple the velocity, then you triple the momentum. If the mass is doubled, you still double the momentum. And if you double both the velocity and the mass, then it is 4 times as great. All right, that concludes this lesson on momentum. Stay tuned for more.